All right, we are on page 1 of notes 9 of Calc C, and we are going to be talking about something called a power series. So a power series is a very general type of thing. We actually know something that is a power series. Actually, we know several things that are power series. We just need to figure out what they are, although you could probably guess. So let's just make sure we understand what's happening. So if we have a summation with, so we start at 0, and then we have a finite number at top, and there's no additional variable, right? There's just the index. So we're counting n, and n is here, and there's nothing else. This is just a series, right? It's, you have a bunch of terms and you add them up. That's a series. If we have infinity at the top, then we have an infinite series because it never ends. And we just spent a long time figuring out, will an infinite series converge? Will it diverge? Maybe do we not know enough? So infinite series, like this, for example, is basically 1 over n squared. 1 over n squared converges. So we could limit compare this to 1 over n squared and say this converges. So that's a series of constants, an infinite series of constants. If we have an additional variable, right? So here we have x to the n. So n is our index. We're counting by n, but there's a variable. Then when you expand this thing and look at it, you'll actually see it's a polynomial. It's kind of an interesting polynomial in that the coefficients of the powers of x have a pattern to them, right? So since there's that pattern, you're able to do this. It's challenging to do this with like a random polynomial, but if you have some specific pattern in mind for your coefficients, you could do this for sure. And we have seen polynomials like this. Think about what we've done. We call them polynomials. We've written summations for them. We have seen this. If you go to infinity, now this is where it's weird. We went series, infinite series, polynomial. If you go to infinity and there's a variable, we call it a power series, right? So it's a series of power functions. So a power function, maybe you remember, maybe not. A power function looks like a times x to the n. Let's say a sub n times x to the n, whatever. So it's a series of power functions. So we call it a power series. And it's just an infinitely long polynomial. Like they could have made that choice. Series, infinite series, polynomial, infinite polynomial. Didn't do it though. They went with power series. And that's okay, because you got to go with the vocab that's there and that exists, and it's fine. So power series are really interesting. Now you probably are saying to yourself, like, I've seen something very much like this. Yeah, you have. So a power series, if the variable is x, and we're centering at x equals a, so think about things that we've done so far, a power series looks like this. C sub n, so a coefficient, x minus a to the n, and then you sum them all up. So you get C0, C1, x minus a to the first, C2, x minus a to the second, and so on. Well, what do we know? We know already off the bat, I don't know where to put this. So if c sub n is equal to the nth derivative at a over n factorial, this is a Taylor series. So a Taylor series, it turns out, is a specific type of power series. It's the one that we're the most interested in. But in general, a power series just needs to have a pattern. So it doesn't necessarily need to be the case like up here. This is a power series. 1 over n squared plus 1 is our c sub n. And then we're just like multiplying that in. Like, why are we doing that? I'm not exactly sure. You make up any pattern that you want, call it the coefficients, and then just go with it. You get a power series. If the coefficients follow this particular rule, right, nth derivative over n factorial, then it's a Taylor series. Taylor series are power series. Not all power series are Taylor series. Taylor series, however, are the ones that we're the most interested in. If you center it at 0, Maclaurin series, we already know that. So the main question that we're going to be interested in is really like asking, what's the domain? But for a power series, we ask, where does this thing converge, right? And so I always think like initially it's like, what does that really mean? Well, what it really means is a power series is basically a function. So what are we allowed to plug in? Like sort of what's the domain? So we're looking for kind of the domain. The interval of convergence is sort of the domain of your series. And so we're going to be obsessed with finding that. So let me highlight that for you though. So I'm looking for like a different color. The interval of convergence is basically the domain. It's the values you can plug in and get a sensible value back. So with most series, you can plug in like anything. It's just a question of like, when you plug it in, do you get anything that makes any sense at all? The interval of convergence tells you where the values are that you can plug in and get a sensible thing. So we need to know how to find that. And we also need to know, like, this is kind of like an interesting little factoid. So it says, for our power series, so for this, one of the following is true, and only one of the following. So it could be the first one, could be the second one, could be the third one. Either the series converges only at A, like the only value that you can plug in and get a sensible value back is A, is the center, the only value. I'm of the opinion this is kind of stupid. I'm sure someone can provide a really good reason why that's not stupid, but it seems to me like instead of having a real series there, you just have a point. You have basically an ordered pair. Plug in A, get B, and you get the ordered pair A, B, and that's it. Nothing else makes any sense. That one's weird. All right, for the next one, first of all, do we know this symbol? I think we do. There exists, so there exists, so there exists an R greater than 0 such that the series converges absolutely, which means that when you plug in any value in this interval, you get a series that will converge absolutely. You could use your series tests on it, throw absolute value around it. It will converge absolutely if the absolute value of x minus a is less than r, and diverge if the absolute value of x minus a is greater than r. So what does that mean? That means that you have kind of a line here. You have a, you can go r in this direction, you can go r in this direction, and anything in between those, anything in here, you'll get a series that converges absolutely when you plug in the values. So like if this is 3 and this is 10, let's just say, so this is 3, this is 10. So that you can go between -7. Why 3? I don't know. Let's say this is 0 and this is 10. You can go from -10 to 10. So if you take -9, plug it in, you're going to get a series that converges absolutely. If you take 8 and plug it in, you'll get a series that converges absolutely. If you take 13 and plug it in, it will be a divergent series, guaranteed. So the one thing that we don't really know in this particular case is we don't know what's happening at these points. These are the danger zone. We got to work those out, and we'll learn how to do that. But that's another possibility. And then the final possibility is that it could converge for all x. We already know, for example, how about a little e.g. I think that's it doesn't really mean for example. Also, it makes me feel like example is spelled like egg example, like eat, I don't know. For example, e to the x, sine of x, and cosine of x, right? Those converge for all real. Here, for example, 1 over 1 minus x, right? That only converged between -1 and 1. It doesn't converge at the endpoints. So you can get any combination of these, assuming there is a r. R is called the radius of convergence, which also I should highlight. I'm like all over the place on these notes, and I apologize for that because I should be better. So this will be the radius of convergence. So let's go with that. And then, so you can get any of these. Like you could open, so that would look like A, so this is A plus R is going to be like an open circle. A minus R is going to be an open circle. And then anything in between is good. You get this. You could get this. Or you could get this. And we need to figure out how to do that. But this is like a big overview. We're not going to do any problems in this video because I don't want it to be a million years long. Although I plainly don't really care about that in most of my videos. But just new ideas, right? Series, infinite series. Polynomial, not an infinite polynomial, a power series. I mean, infinite polynomial would have been so much better, but whatever. And then scenarios, and you got a radius of convergence, and there exists, and some things we know. Taylor series are power series. So we already know a lot about them because we know a lot about Taylor series. So we just have to like expand upon that, and we're going to. So I'll be back in the next video to do some more, and I will see you there.